7.2 of the FIG Working Week 2021. This session is titled, and I'm just going to share my screen as we get started, Cadastral Modernisation and, excuse me, that was not meant to be like that. So this session is titled Cadastral Maintenance and Modernisation, and I'm the chair for the session. My name is Rowan Bennett, and I'm ably joined by Charles Adekora, who I don't know whether we'll have him on screen yet. It'd be great if the back end could stick on Charles to say hello to us.
Hello, everyone.
Good morning, Charles. Great to have you. Maybe a little bit of an introduction of yourself before we get going.
All right, so I prefer to call myself a young surveyor because I've had my MSc title for barely 2 months. And this happens to be my second appearance on FIG, and I'm looking forward to a great session. Over to you, Ron.
Great, Charles. So we'll have Charles in the background monitoring questions and taking comments. So as per all the other sessions, please put your chats into the chat box. We can see them as presenters and the chair and rapporteur, and also the Q&A, we'll keep an eye on that as we go through. Charles, great to have you. As I said, my name's Rowan Bennett. I'm a senior advisor with Cadastral International, and this topic is of great interest to us, cadastral maintenance and modernisation, because it informs a lot of the work we do and a lot of the project work we do with our clients around the world. So what are we going to do in the next 1.5 hours together? Well, our theme is obviously maintenance and modernisation. And what do we mean by maintenance? We'll get to that shortly. But it's often seen as the poor cousin, as we have in the description of the session, to establishment. We tend to put a lot of effort and focus on the establishment of systems, particularly in developing contexts, and less focus and finance often into how we're going to maintain those systems. And this is really important and a really big problem area for our domain, because obviously the success of any land administration system is really heavily reliant on the approach taken to maintenance. So in this session, we're unashamedly giving the concept of maintenance and modernisation a front row seat, or even better still, the centre stage. And we're going to, we've got a number of great speakers who are going to be having talk to us in the session, exploring both issues and solutions around this maintenance theme. So what's the format for the session? Well, we're just setting the scene here, obviously, and then we're going to do a mini world tour, as much of a world tour as you can do in 90 minutes. And that's going to involve looking at 4 different regions and 4 industry specialists, but from both the practical side and the technology vendor side. And then after that session of speakers, which will take around 45 minutes, we'll then break out into a panel Q&A, if you will, and some final says, and then we'll head back to Charles for a final wrap up. So who are our speakers? And these are unfortunately in a rambled order for us. But we'll be speaking to, hearing from Martin Best from Switzerland, Fajar Paramadi from Indonesia, Tim Hodson in the USA, and Brandon Trudelot, and apologies if I've pronounced that wrong, Brandon, both from the USA. But let's just set the scene before we head into that first set of presentations. And I'm just grabbing here from a recent paper that's published under the FFPLA special issue. We heard earlier today on the issue of FFPLA and the 10 years that FIG has put into that concept and associated toolbox. And this is one of the papers from the special issue that Professor Stig Enemark was mentioning, that's been put together by he and Professor Crit Lemon and Robert McLaren. So 30 papers around the concept of FFPLA, or Fit for Purpose Land Administration, and a few of those papers focus specifically on this issue of maintenance. So why is maintenance so important? Because it ensures that upfront financial investments don't go to waste. These land administration systems that we build can cost upwards of $20-30 million spread across sometimes 5 to 10 years. and sometimes much more than that. And if there's no time put into maintenance, no time put into sustainable business models, then that investment, which is often paid for by the people via loan within a country context, completely goes to waste. And we've seen that too many times in the recent history of land administration investment. It also makes sure that the community benefits of land administration that are intended are sustained into the longer term. And that's obviously the reason we're doing land administration. And there's a whole bunch of reasons that we do land administration, from securing tenure to enabling land markets to ensuring fair land taxation, and a whole range of other benefits which are now more closely associated with the Sustainable Development Goals. And that's why maintenance is so important, to enable that reporting of information, for example, to the SDGs. It also, maintenance and ongoing maintenance provides the opportunity to improve our services as land administrators, whether we be from private sector or public sector. The idea of maintenance and maintaining systems is important. It offers us this chance to improve our services and often lower the cost of our services. It also enables, as I mentioned earlier, this responsiveness of our land administration systems to changing societal concerns. And as I mentioned, that is often couched around the Sustainable Development Goals in the modern context. And if we've got systems that were constructed or based on technologies and processes that were around in the 70s or even earlier, we're missing the opportunity often, or not capable of keeping up to the demands that society has or has placed on us. So why do we get it wrong? I think there's a lot already written on this. There's a lot already known about this. And so just a few quick points on this. Care factor of higher level government is often less interest in maintenance rather than establishment, because establishment comes with a project, it comes with budget, and it comes with higher profile, whereas day-to-day business tends to be of less interest for government. Or higher level government. So we can see a complacency sometimes creep in, and this applies to even developed contexts when we might have complete land administration systems with up-to-date records. The idea of maintaining or upgrading a system that tends to work and bringing it into a more modern context is often not on the highest priority of government. You can also have inertia within the land administration sector itself. It's working, it's doing the job good enough, why bother upgrading systems? There's also, as I said, a focus on project cycles, particularly in donor projects. So this focus on getting a system built over a period of 3 to 5 years rather than thinking longer term, how do we make it sustainable? And a whole range of issues around financing, mandates for doing for actors in projects to do longer term provision, or having business models around that enable longer term provision of systems rather than just the build of the system. And also issues of capacity. It's one thing to create a team or bring in a team to build a system over 3 to 5 years, but what about the longer term maintenance of that system when the project's finished and the project team's up and left and moved on? Also, community awareness. It's one thing to build a system and have it in-house in government and working and chock full of data collected over a short amount of time, but then what about the community? Are they aware that once they've been registered once, that they should keep that system up to date? Because if they don't, obviously the records that we have just become a historical reflection of what was happening at a particular time within a jurisdiction. And having the capacity to maintain that system and having training programs is another key issue. Also, another issue is sustainable standards and partnerships aren't put in place when we're undertaking land administration projects. But before we go on to our presentations, just to give us a little bit of a setting as to where each of our presenters fit in this morning, what exactly is maintenance? Because I've been throwing the concept around, but I haven't really defined it so clearly. And once you start talking about this term to different actors and members of our land administration community, we often find we've got different views on what exactly it is. So here's a pretty simple, hopefully, schema of how we can break this concept down. And I'm just going to try and show you where our different speakers fit before we jump to our first presenter. So the big differentiating factor we often talk about in our domain is maintenance versus establishment, and maintenance being everything that is not establishment. But that's where it starts to get a little bit more complicated, in that we have this distinguishing between the upgrading of systems and the updating of the data within the system. And they're two different processes. So we've got the day-to-day updates of transactions and upkeep of the data in the system versus these larger, often also project-driven initiatives that we often call upgrading or renewing systems. And so that's quite a big differentiating point there between in this world of maintenance. And if we stay on the upgrade side of things, we have project-based approaches to upgrading systems, which are often a set portion of money over a set period of time to upgrade a portion of our system, versus continuous improvement and continuous upgrades. In some land administration systems and organisations have inbuilt into them innovation processes that enable this continuous improvement and upgrading of their systems. Others do not, and that's where we start to see legacy systems become an issue over time. When we break that down further, we have institutional upgrades, so that can be all issues around changes to laws and business models and organisations, which flows on to questions around public versus private sector data or public versus private sector interests, deeds versus title. These are all upgrades that can be made within systems at any given time. Then we have information quality upgrades, which is the second box here, where we're talking about either well, not necessarily incremental improvements, but significant changes to processes to improve the quality of either our spatial or person or rights related data into the systems. And then we've got the actual technology backend upgrade itself, where we might bring in new servers or move to a cloud-based system. And again, that's another type of upgrade we can take on. Then we have, jumping back down over here, the issue of updating, which is where we tend to get into trouble with keeping systems up to date after we've had that initial establishment phase where we've gone out and done a lot of data collection. In the literature or in practice, we tend to talk about systematic versus sporadic collections. So if we think about that in a practical sense, we're often doing our tax valuations on land in a systematic fashion every, say, 1 to 2 years, whereas sporadically we're recording land transactions. And in that box, we can be talking about the spatial component, which we're going to see some presentations on today. We can be talking about the rights component or the people information in those systems. So if we just have a look at our presenters, we got Martine, who's going to present really on public rights, a registry in Switzerland, and so she really is fitting into that part there around really upgrading what it means to have a cadastral system with the full collection of different rights over land. Fajar from Indonesia is going to really talk about a method and procedure involving machine learning and automation, where it's about upgrading the quality of information from old paper-based documents into the modern system that they're building there in Indonesia via ATR and BPN. Tim Hodson is going to give us a presentation, and he may correct me here, on techniques coming out of history that are available for us for updating the spatial aspect of the information around parcel fabrics. And Brandon's going to give us somewhere in the middle too a presentation around the technology opportunities that exist out there for keeping our land administration data up to date. So without any further ado, and that's been quite a lengthy introduction, but I hope you've bared with me until this point, I now want to invite our first speaker, and I'm just going to stop sharing my screen. I'm going to invite our first speaker, who is Tim Hodson. Tim, welcome along.
Thank you, Rowan.
And I will hand immediately over to you, and I'll let you give yourself your little CV introduction before you get into the content for us.
Great. So you can hear me okay, and you can see my first slide okay?
Wonderful. Yep, we've got it all.
Okay, great. Thanks, Rowan. That was a great introduction. And yes, you have it right. I will be focusing on the spatial aspects of maintaining cadastral measurement data in GIS. My name is Tim Hodson. I work at Esri as a product engineer in software development, and I work on parcel fabric technology. The topics in my paper cover a fair number of different elements, but we're going to be focusing here specifically on these topics where we talk about, I'll talk about defining the quality of cadastral information. What exactly do we mean by the quality of cadastral information in a spatial context? I'll introduce the parcel fabric, its concepts and data model, and then maintaining the data by assessing and improving data quality within the parcel fabric. And part of that includes least squares adjustment engine, least squares analysis, and applying the updates from a least squares engine to a parcel fabric's points. So first of all, accuracy in parcel data. What do we mean when we talk about accuracy in parcel data? When in the context of spatial information, we're talking about good attribute data, good topological connectedness of the data between different parcels, and relative accuracy. And I'll go into more depth of these each in turn. And those three fundamental elements of attribute topological and relative accuracy are the building blocks to get the ultimate, which is spatial accuracy and ground truth in our digital systems. So by attribute accuracy, we're talking about the information from the legal document on land records. Do they match what's in the database? Do they match what's in the table for this particular line? For example, we have a bearing and distance on there, and do those match what's in the database? In addition, we have the ability to look at the quality of a parcel, so we can see that the loop of lines that form its boundaries, do they mathematically close? Is there good misclose distance? Is the misclose ratio good? And those are all driven by good attributes. We can also talk about topological accuracy, and this means no gaps and overlaps between parcel boundaries. So we want to make sure that all our line work is coincident and our points lie on the lines that they're supposed to lie on. And so we have the ability to align our parcel boundaries. Also, part of topological accuracy is where we have points, where we have multiple points in a digital system where there really should only be one. In this case, you can see here that we have a control point, and it's really supposed to be defined by a single location. And so we can merge these other close points that are nearby into that single control point and get good connectivity and make sure that we have redundancy with all of our other line work that connects to that control point. In our system, we want to be able to make sure that if we move a point, that the lines stay connected to that point. So regardless of the actual accuracy of the coordinate itself, we want to make sure that we have connectivity within a boundary network, because that's part of maintaining accuracy. So when we move lines, we want the points to stay connected. When we move polygons, we want the lines and points to stay connected, and so on. Relative accuracy has kind of a hierarchy of elements to it. You can have relative accuracy between different layers and different data sets. You can also have relative accuracy between parcels and points within the same data set. And then there's also the notion of relative accuracy within a single feature, and I'll talk about how we can compare the geometry or the mapped geometry versus the measurement attribute. So relative accuracy between layers, here you can see we have an ortho imagery, and we don't have very good accuracy with the actual relative accuracy with the line work of the parcels. And on the left image, you can see that our zoning boundary is misaligned with our parcel boundary. So these are the sorts of things that we want to improve and get good relative accuracy between different layers. And then relative accuracy between different parcels. So within the same data set, if we have, for example, a street that is 17 meters wide, we want to make sure that we can maintain that relative accuracy of that street, regardless of where it may be positioned. So if this entire set of parcels were to move somewhere else, we'd still have that 17 meters relative accuracy between these two parcels. And then relative accuracy within the same feature. So here again, if you can see here, we have a distance and a shape length. And so those are two different things that are stored in the database, the shape length representing the mapped representation of the line length. And then there's also the measurement itself. So if I move this line, you can notice that the line's shape length has increased to 12.6 meters, but our distance measurement has not changed. We don't want to alter our distance measurement because that came from the record, and that's defining good attribute accuracy. So we want to maintain that good accurate attribute accuracy, but then also attempt to get good relative internal relative accuracy between the shape and the actual measurement values. So we want to avoid this sort of distortion, and we want to get the distortion out of our data in this way. And of course, the ultimate is spatial accuracy, but part of spatial accuracy also means correct feature identity. So not only should you find the correct point in the field to survey its location, you also need to, once you have the coordinate of that accurate location from the field, you need to be able to identify the correct digital point in your database in order to assign those coordinates to the correct digital location within your land information system. So moving on to the parcel fabric concepts and data model, and how do we support this maintenance of accuracy? We have the parcel fabric. It is a controller data set. It has lines and polygons. For each parcel type, there is always a line feature class and a polygon feature class, and there can be multiple parcel types within your parcel fabric. We also have a record feature class, and every row in a record table represents a legal instrument like a subdivision plan. And so a single record might have multiple parcels held within it. And then, of course, the important part of the topic of this presentation is about maintaining topology and getting good and assessing topology accuracy, and also attribute rules, and using error features to identify places that need to be sorted out and fixed. And these three elements are the aspects I talked about earlier with the building blocks of ground truth and spatial accuracy, of the topological, attribute, and relative accuracy. So maintaining a parcel fabric, we can assess topological quality using our topology engine. So this allows us to make edits to our data. And when we make edits to the data, you can see that it gets tracked. So there's a footprint that's created when any edits are made, and you can see that it is these purple polygons. And then we can validate that extent and say, okay, we have a dirty area here that we need to validate, and see what we get. The dirty area goes away, but in what replaces it are some error features. So we can see that we have lines that have no parcels. We have missing points on the ends of lines. We can do another edit to fix this data. Once we've done the edit, we again get a dirty area because we have an edit has been made in the database. So now we can revalidate this dirty area to clean it up. And here you can see that we've back to a state where we have no error features in our data. So we've corrected. We found the problem, and we've corrected it using our error features. Similar to topology, we also have attribute rules. Attribute rules can be calculation rules, constraint rules, or validation rules. Validation rules are things like what I talked about earlier. We can identify distortions between the geometry and the measurement attribute. And we go through this animation here. We can see that when we evaluate our rules, we again get error features that show places where we need to do some work. Like we have lots of features here that must have a record, so they are not inside a record yet. And we also have a distance must match within. So the line shape length must be within a certain tolerance of the actual measurement itself. So you can see that there's some work to do here in this data in order to fix it up and clean it and explore further to improve the quality of this information. Moving on to least squares adjustment engine and analyze and apply. And this is really about achieving that ultimate goal of using those building blocks within a least squares adjustment to achieve ground truth and spatial accuracy. The parcel fabric integrates the Dynadjust engine. It's developed by Geoscience Australia, and it's an open source. The code is all available to everybody, and it was published in a GitHub repository in August 2018. And we've incorporated it into the fabric, as I said. And it's supported through, we support two adjustment types through the fabric. One is a consistency check, which is like a free network adjustment that does not require control points. It's simply a validation of the network itself. And then there's also the weighted least squares adjustment that requires control points and helps us get the best fit of all of the measurement data onto those control points. This has been implemented as two separate geoprocessing tools, one to do the analysis, the Analyze tool doesn't change your parcel fabric at all. It just presents information that you can act on. And once you're happy and you're willing, you're happy with the results of your analysis, you can then apply the results of your least squares adjustment to improve and update the positions of the parcel points. One of the key aspects of bringing a least squares adjustment into a GIS is being able to visualize this analysis results. Typical text files of the adjustment results look like this. So and this is very difficult to read often and get access to or to interpret. And what we really want to do with what we do with the parcel fabric is we take these types of results and present them and visualize them in the GIS system so that we have a kind of a more intuitive view of the accuracy of our data. And so we use cartographic tools to present this information. At the small scale, zoomed way out, we could have things like heat maps to show the position uncertainty, where we have low accuracy and high accuracy, where we may need more control points, or where we may need to do some further research and correct measurements. We have the medium scale where we show point shift vectors. So these are how the points will be moved when we apply our least squares adjustment. And then zoomed in way down to the large scale, we have error ellipses on individual points, so giving us more information about the statistical information of these points, metadata on those points. So here's an animation showing this is data from Texas, and this is an animation showing doing a consistency check. So in this case, we're choosing our parcel fabric. We're going to keep the analysis type as consistency check. So we're not going to use the control points, even though you may see them on there. And then the control and running the adjustment will update and add analysis layers. You can see those on the left-hand side in the table of contents. And you can see our iterations happening here as we iterate through this least squares adjustment. And then the results are presented on in these analysis layers on the map. And you can see that we have some very large red lines. And these are indicating the outliers where we have data where the information on the record does not match the underlying cadastral document. So we have on the record 526.14, whereas we have 532.13 in the actual record. So we want to be able to find and identify those places and fix them, and we use the least squares analysis for that. So that brings me to the end, and I appreciate your time, and I'll hand it back to Rowan. Thank you.
Great. Thanks very, very much, Tim, for that overview. Particularly of interest there is your final sections on the least squares adjustment and the visualization packages around that, because we know a lot of jurisdictions at the moment are looking to upgrade their previous cadastral fabrics, which maybe still have heritage but dating back to original scannings of cadastral maps and so forth. So I know there's a lot of jurisdictions, and maybe we can talk a bit about that in the discussion section at the end on how that's all going and the role Esri's playing in some of those projects. I know here in Australia it's happening. There's some work also happening in the Netherlands doing these back capture from the actual survey measurements themselves with a view to upgrading the complete fabric. Charles, have we got any quick clarifying remarks or questions in the comments at this point?
Currently not, so we can go on.
We can go on. Thank you very much, sir. So we'll head on to our next presentation, which is from Brandon. And I'm just getting the title of Brandon's presentation here today. So Brandon taught a lot today, and I'm again apologizing for my pronunciation. And this was originally to be presented alongside with Timothy Thaler. So again, looking at some of the technology vendor side around these issues of maintenance and modernisation opportunities in this space. So I think these two presentations go quite nicely hand in hand, what we've just seen from Tim, and then building onto Brandon's presentation, which is on the digital submission challenges and opportunities with the next generation parcel fabric. So over to you, Brandon.
Yeah, thank you so much, Rowan, for that great introduction. And thanks, Tim. So yeah, if you just heard, the focus of this presentation is going to also be on the parcel fabric, the same parcel fabric that Tim just got done speaking about, but a little bit of a different topic on the same, and that is specifically on digital submission. So we're going to talk about digital submission in terms of the challenges and some of the opportunities. But I am Brandon Tortlet, as you just heard. Sorry, Rowan, we didn't clarify ahead of time. So it's just Tortlet, just 2 syllables. So it's very easy to say. And I'm part of the land administration team here at Esri. So we're going to dive in and talk about digital submission. But before I delve too much further, it seems to me we should do a little level set. What is digital submission? So what are we referring to there? And so this graphic will help to illustrate that a bit. So it's this notion that when survey and cadastral plans are submitted in a digital form in lieu of paper and PDFs. So that's a quick and simple way to say it from a surveyor's context. So the key point on this is that, certainly we can all agree digital data is certainly more shareable and discoverable, but the real value, the return on investment that can be realized from this is in that upfront self-validation of survey data prior to submission or in the process of submission. And so there we look to use identity, rule-based engines, data standards, automation as much as possible, right? So that as opposed to a human being having to look at each submitted plan, each submitted survey plan and piece of data and so forth, and manually review those and kick those back and so forth, resulting in backlogs and so on and so forth. So if we can kind of be thinking along those lines, that's what we're here to talk about today. So a bit about some of the experiences recently with digital submission in the recent past. So we've got a couple of examples here from Australia, Singapore, and New Zealand. So these examples are all focusing on using the Land XML, which I'll just say briefly is a data standard. It's a transmission standard that has been used. And the experiences have been essentially this. So in the case of Australia, it is a data standard. It's optional to use, but it is an option that is given when they're e-plan guidelines. And they've had some automation that has taken place. This more or less tracks with the paper. In Singapore, now they're a little bit of a different implementation there. So they actually have a registered surveyor's portal. And so some pre-validation actually occurs in that portal before it is going to the relevant land agency. And actually, not to foreshadow too much, but that example, that method is actually pretty key to our thinking currently here at Esri. So stay tuned for that. But that is, again, using that Land XML as the methodology. And then lastly, we have New Zealand. So that is where it is a mandated data standard. I'm using their Land Online system to do that pre-validation. So we're going to talk a little bit more about all of those things. And of note, then with the New Zealand example, so there the surveyors can actually, prior to or as they're prepared to do some surveying, they can actually extract from that same portal, that same Land Online system, relevant reference data, so controls and existing data of an area that they are going to survey, and they can utilize that to their utmost. So, so again, Land XML is the key there, and that's really what's been used thus far. Now, I mentioned in the title, we're talking about some of the challenges and some of the shortcomings. So the real key issue here is that when compared with the Land XML or XML in general, there are more elegant or perhaps efficient transmission standards and data languages such as JSON. Land XML requires moving from files to services. There's a question about how well it scales, which of course is very important, right? If you're a large agency or you have lots of submitted plans, a lot of surveying work going on, a lot of construction and so forth. So there's a question around that. And the reality is that the voluntary adoption in the case of Australia, for example, with that Land XML has been quite low. So let's say only around 5%. There was a study that was done that found around 5% of the time that's been utilized in survey plans being submitted. There is a perception that the data is becoming the source of truth versus the representation of the plan itself. And the reality is that there's just simply been insufficient incentives for surveyors to adopt that Land XML protocol. So the idea would be that the benefits simply have not translated to any one party in particular enough to compel them to say, let me go ahead and use this XML as my digital submission method. So just has not been enough in that regard. And then lastly, we do have the issue of occasionally with LandMXML files, when we talk about rendering those, sometimes those produce a poor enough quality product that the experience has been that actually sometimes the survey plan itself has to be submitted in a separate or in parallel to the LandXML file as a raster image. So now we're duplicating, we're not really saving time. And so not surprisingly, that detracts from the adoption of that method. So we here at Esri, and just to kind of also level set on this presentation overall, so what we're really talking about here is, in the next couple of slides, is simply going to be a presentation about how are we at Esri thinking about and what are some of the opportunities that we foresee in the context of the current Parcel Fabric and ArcGIS Pro, and where do we see things going, what's our vision, and where do we see the opportunities for really being able to automate and streamline that whole process. And so the pieces involved here would be a named user, an Esri named user. I'll talk about that on the next slide if you need a little explanation there. And then we have the Parcel Fabric itself, again, the same one that Tim talked about. There's other sessions here at the conference about the Parcel Fabric, include a workshop on Thursday if you'd like to learn more about the Parcel Fabric. And then the Parcel Fabric actually has its own RESTful API. So API being a programmer's interface, we can pull data out and things of that nature and perform automation against Parcel Fabric itself. So that's very powerful technology. And then lastly, we do have an ArcGIS for AutoCAD plugin, which I will also talk about. So these are the three key pieces of technology that we are intending, or our vision is that these will all fit together into ultimately a digital submission solution. Okay. So I mentioned named users, though, for those that are not familiar, not sure what that term means exactly. It's essentially this, is that we can have different types of user licenses or access setup, or accounts rather. And in this case, essentially it comes in 5 different flavors, and it's about enabling identity and the capabilities, the functionality that you need, and also enabling the apps that you need to do your work. And so conceptually, it just maps over or corresponds to the human beings and what they need to do. So for those that are simply viewers, that's pretty straightforward, all the way up to the GIS professional that needs to have full functionality, access to all of the applications, including ArcGIS Pro, and a couple of gradations in between. And there's also extensions for Insights and Parcel Fabric as well. So this is also a piece of it, is being able to get access through the ArcGIS named users. So Parcel Fabric works across the entire ArcGIS platform, and there is a direct relevance to this topic here today, but this is kind of a zoom out slide, right? So the notion here is Parcel Fabric is everything that Tim said, but also in terms of system architecture, it is a product that works on an enterprise ArcGIS implementation in the portal, and it actually works on web services rather. And so what that enables is, on the one hand, you have your desktop users that are working in the Parcel Fabric, sort of like the workshop I mentioned, right? So they're doing editing on a day-to-day basis. They're doing maintenance. There's that word, maintenance, and so on and so forth. We can also access the Parcel Fabric in devices out in the field. So for collecting data, seeing data in the field on various mobile devices. And then lastly, we have the notion of bringing Parcel Fabric into third-party business systems, web-enabled business systems, and so forth. So for instance, there's the notion of web editing with a parcel drafter, where you can actually key in a legal description and draw a parcel right there in a web browser. It's very powerful technology. And you'll notice our topic here today, digital submission, actually falls under that topic right there, right? So it's an example of where we're actually taking Parcel Fabric and connecting it to third-party business systems. So it could be AutoCAD, it could be the sort of surveyor's portal I alluded to a few minutes ago, and being able to call that functionality, which I'm going to get to in a couple of slides, being able to call that Parcel Fabric functionality into other systems. So that's where this fits in the larger scheme of the different things that are possible with the next generation or the current Parcel Fabric. So I mentioned this earlier. So what this is an AutoCAD plugin, ArcGIS for AutoCAD. And as it says on the screen here, it's a free plugin that simplifies the way you share and synchronize GIS content between AutoCAD and ArcGIS. So you can enrich your CAD drawings with ArcGIS hosted maps, imagery, and geographic features. You can edit geographic features within AutoCAD and use them for navigating the drawing through location. So essentially, for our purpose, this would be the ability to connect to, if you're going to do surveying in a given area, that agency's existing parcel fabric, we can actually bring that right into AutoCAD, and you can view that data right alongside the drawing or the surveying that you are laying out in your AutoCAD environment, and you're actually able to access that and see that authoritatively, a current picture of what that looks like right inside of the AutoCAD environment that you're already using. So this is kind of the key here, right? So what's on the roadmap? So as we say here, today the digital submission workflow faces some challenges, but it's definitely on the Parcel Fabric roadmap, okay? So this is where we see the opportunities. So as it says here, clients of any type, they need to be able to support branch versioning. So the user that it creates a version, and they actually submitted the proposed survey plan against that. And it's not a post and reconcile kind of thing. It's simply using that as a vehicle to submit that proposed survey plan. And then that's where the REST API comes in. So that's essentially what my screenshots are here are conveying, is this idea. We're actually calling the validation service of the Parcel Fabric through the API. And so we're actually working against some of those pieces of functionality. So we have the validation, the different types of functionality as far as build, merge, clip, and so forth. And all sorts of different functionality. And so that's kind of our vision in a nutshell, is that through the submission process, the surveyor will submit the plan. The version will be created to load that digital submission data. And then the client will need to be able to call those same services. And there are automation opportunities too, potentially using Workflow Manager and so on and so forth. So the point of this slide is this is the opportunity. The building blocks are there, and we're just putting them together into a true digital submission solution. And so it will be quite elegant, and it will actually work directly with the Parcel Fabric. So in conclusion, again, the slide here kind of explains it very well. Assuming this capability is built into the plugin into various surveying portals, it will provide the following benefits. So you get that real-time access to survey data, so you can download reference data for your survey, synchronizing between AutoCAD and ArcGIS for folks in your profession. And again, surveyors need to access the Parcel Fabric functionalities to check and validate plans prior to submission or in the process of sending it to that portal in the submission process. And it certainly reduces the likelihood of errors and associated back office examination time, a backlog of this type of work to be done, and so forth. And I think we can all agree that is a great maintenance topic, and handling the influx and being able to streamline that as much as possible using ArcGIS and the Parcel Fabric. And so with that, I will go ahead and put my last slide up here, and I'll let you come back onto the screen here, Ron.
Thanks very much, Brandon. Great presentation, and really interesting to see of the interoperability tools that are going on between ArcGIS and AutoCAD, for example, and also this automation and validation tools that are becoming increasingly used to basically minimize errors, aren't they? So really useful and an update on the Parcel Fabric from both your presentation and I think Tim's. Charles, do we have some sort of clarifying remarks at this stage for Brandon? Oh, there's that line again. You've got to put your mic on.
Cheers. So there are not clarifications to be made, but main questions that we'll discuss after the presentations.
Okay, yeah, I can see we've got some questions there from Jean-Francois, Michael Barry, and a few others. So we're definitely going to come back to those.
Sure.
Call at the end of the session. And also thanks to Norel also and Brent Jones putting up some further information very related to the topic we're covering here. Okay, Brandon, so hang around. We're going to bring you back on at the end to grill you with some questions. Okay, let's move to our third presentation. We're moving away from the technology vendor now. It's my pleasure to introduce Martine Bess, who, as I mentioned earlier, is from Switzerland, and she's one of our young surveyors, and she's going to be presenting on RRRs, or public restrictions and responsibilities and rights, and that's also an important part of system upgrade and improvements that we're seeing in the cadastral space. It's actually, as we know, dates back to Cadastra 2014. One of the key principles of that was to bring public lands and public rights and restrictions integrated with our more traditional private right cadastre. So Martine, the floor is yours, and look forward to your presentation.
Thank you, Ron. So I trust that you can see my screen now. So hi, everyone. So I'm Martine Bess. I'm a university student in the School of Engineering, HEIG-VD in Switzerland. Today, I will talk to you about the Cadastre of Public Restrictions on Land Ownership, also called PLR Cadastre, in Switzerland. So just for a quick introduction, this is not new for you probably, but as owners, when we can't really do whatever we want with our plot of lands, we actually have to respect some private laws, but also some public restrictions. So about this PLR, we've seen that since last years they've been increasing, so that it has been estimated nowadays at around 150 in Switzerland. And the problem with those is that they are issued by different authorities in different departments. Some of you may know, but in my country, we work at 3 different authorities level, like the Confederation, the cantons, and the municipalities. So for example, if you want information about the railways, which are managed by the Confederation, we have to check to their department. But then if you want information about the zone in which our plot of land is in, we have to check with the municipalities. So it's really a big spread of information between various departments. So this spread leads to a loss of time, a risk of forgetting, and a lack of legal safety. But actually, this is not only concerning Switzerland. These issues were already discussed in an earlier publication of the FIG from 1998, which was called Cadastre 2014, A Vision for Future Cadastral System. So it was a result of the working group of the Commission 7, led by, who you probably know very well, Jörg Kaufmann and Daniel Stöller. So they had to study how cadastral system would have to work and what it would look like in 20 years. And this lack of legal safety was one of their conclusions. So in a way, we can say that the PLR Cadastre is the Swiss realization of this vision. So now that the main theme has been introduced, we can jump to the subject. What is actually the PLR Cadastre? So it's an official information system which concerns the public restrictions on land ownership. It has been developed by the Federal Office of Topography, Swiss Topo, at the cantons. And the project was launched in 2012. And now, since last year, it covers almost the whole territory. Only one canton still has to implement the tool. So here is a list of all the most important public restrictions we can currently find in the PLR Cadastre. So you can see there's quite big variety. I say for example, the special planning I already introduced earlier, or the railways, but you have, for example, about the forests, the motorways, and etc. Important to know is that this list is expanding. For example, the blue colors mean that this is the restrictions that were introduced or are being introduced now. So what I want to show in this image is, there's a big variety of restrictions that come from various operators and various departments. So now I just want to highlight the fact that the PLR Cadastre is not, we can't really call it what I call the classical geo portal. It has some added value. Because yes, actually some of these restrictions, you could already find them on some other geo portals. For example, here in the example on the left is the geo portal of one of our French-speaking canton, Vaud, where you could already find plan for land use municipality plans. But they were only here for informative purpose, meaning that, yes, you can see in which zone you are in, but you don't know when the information came from, what does it actually mean, etc. So here it's really where the PLR Cadastre distinguishes itself, because first it gives a complete overview of all restrictions about your plot of land. But then, which is really important, is that the information is completed by the legal provisions and the legal bases, which are sources to the restriction. So you can see the example on the right about the same plot of lands. Here you see all the legal provisions which concerned it. and that are really easy accessible just by clicking the link. And another added value of the PL Cadastre is that the users can easily have a static extract summarizing all the restrictions concerning his plot of lands. So now we'll go to some technical aspects. So actually the implementation had to face several challenges, as always in every project. So first, as we saw earlier, the restrictions are quite diverse. They come from different sources. They are established by different authorities, which have different needs. So there's quite a heterogeneity in the restrictions. So they had to find a way to know how to standardize this data. And they did that by creating a framework model, which is the basis to all the restrictions. So this framework model guarantees the interoperability between all actors. Then the second challenge that they had to face is the dematerialization of the information. Yes, actually, a lot of documents are still only available in paper formats, which means they had to be a huge process of digitalization of these documents, which is not that simple to do. It's quite a delicate task because, first, of course, they need to be accurate in this transcription, which means they have to have control in place, etc. But then they also have to adjust to the data of cadastral surveying. What I mean by that is that this paper plan were issued really years ago, where you can imagine the quality of cadastral surveying was not what is it today. So to put it in the database today, it was necessary to make some adjustments. So now we have a quick overview of the result of this PL Cadastre nowadays. So first, what are the benefits? Well, the main benefits is now that the information is centralized and easily accessible at all time. There's no the need anymore to go to every services individually and check everything, double check that we didn't forget everything. Now everything is at the same place. So this increases the legal safety of land property. And then actually the creation of the PL Cadastre is in accordance with the strategy of our governance in the field of digital transition, as they want a better availability of the information for the people. But then, of course, the PL Cadastre is not perfect yet. We can identify some limits to these concepts. First, even though the goal is to have a complete overview of our restrictions, this is actually not the case yet. Not all are available at the moment. And then another problem is that the PL Cadastre does not enjoy public faith, which means that the actual paper documents, legally signed documents, still have to be consulted. But we hope that in the future, in parallel with the digital transition, this will not be the case anymore. So I would like to make maybe a quick return on investment. Actually, it's quite hard to quantify direct cost saving, as you can imagine. But they still try to evaluate if the impact of the PL Cadastre by doing a survey. They conducted a survey with all the operators who works with landowner property, as for example, the surveyors, of course, the municipalities, the architects, etc. And they also compared between cantons which already had implemented the PL Cadastre and some others that hadn't yet. So the result of this survey is that yes, the PL Cadastre had an impact and it was positive, as some important time saving and efficacy has been shown. So now a quick conclusion. Now this tool in Switzerland has been seen as an essential tool for all operators who work with landowner property. And it will be, of course, improved in the future. It's in the strategies, in this strategy of the Confederation to improve it by expanding it to new restrictions and diversifying the kind of restriction. So thank you all for your attention today.
Thank you very much, Martin. Much appreciated. Really nice presentation there. I think one of the disappointing things about this e-conference or e-working week is that we don't get to hear all the applause. And I'm sure all our participants are sitting there in the evening or in the morning, wherever they are, heartily clapping away for your presentation there. So thanks very much for it, Martin. There is some questions that we're getting coming up in the comments, but as I said, we'll cover those later. So thanks very much. And on your presentation, I do recall, I think it was around 2005 or 6. I remember sitting in an FIG working week. Might have been in Munich, and I remember one of your colleagues. His second name I think was Maizare. I don't know if he's still working there in Swiss Topo, but he was talking exactly about this issue back then, and the concept of needing the PLR cadastre. And it's great to see over this now, I'm showing my age a bit actually, over this 15-year period, how it's moved from concept to implementation to now complete coverage of the country. So really impressive stuff. I'm sure there'll be some questions around that area. It's certainly a topic that's dear to my heart. So thank you very much, Martin. Okay, we're going to move on to our final presentation, unless Charles interrupts me and says there's a pressing clarifying remark, but I think we'll move straight on to our final presentation. And thanks all so far to keeping really close to your time. It's been really good. This presentation, we're now sort of moving over to the Oceania or Asia Pacific region, where the sun is just starting to come up. And we're going to have a presentation from a team out of Indonesia, looking at a whole range of things in this presentation, and it speaks to some of the issues we've already covered in some of the other presentations. So the topic of the presentation is the implementation of the TensorFlow framework with the API detection object method and a convolutional neural network on previous or historic land documents linked to ATR BPM, which is land agency there. Now we've got potentially two presenters here, so I'm going to introduce it as Fajar, but it could also be Donny who's presenting. So I think we've got them both on screen there, and beautiful. We're now got them sharing screen. So Fajar and Donny, the floor is yours.
Okay, thank you. I want to introduce myself. I am Donny Ferdiansa, and my partner is Fajar bin Permadi. We are from Indonesia. We are assignment student in National Line College. We are employed at the Ministry of Grant Affairs and Special Planning and National Line Agency. Okay, today I want to talk about our paper. The title is Implementation of the TensorFlow Framework with the API Detection Object Method and Convolutional Neural Network on Land Document in Electronic Service at the Ministry of Grant Affairs and Special Planning in National Land Agency. Okay. This is outline of our presentation. The first, the background and purpose of the study. In this moment, I want to tell the existing problem, the use of virtual counter and the use of object detection, technology using the TensorFlow framework and CNN algorithm. Second, method on the study. Describe the method used in the study. The research spares the test data, training data, and then perform segmentation and normalization, labeling, classification, verification, and validation of land document in stage. Third, a brief literature review. Explain theoretical studies based on expert opinion, and short from latest book, journal, proceeding, and other sources. Fourth, results and discussion. We want to talk about analysis of change in measurement book and land book from 1960 to 2021. Test the accuracy of the CNN algorithm and land document, development of TensorFlow framework and the CNN algorithm, and the future virtual land counter. And the fifth is conclusion and acknowledgement. Okay, Ministry of Agrarian Affairs and Special Planning National Land Agency, as one of the government agencies providing public service, they continues to improve by developing electronic-based service. This is in accordance with the fifth point of strategic vision of the Ministry of Agrarian Affairs. In 2020 to 2025, to create a modern service office that provides an electronic product, services, and information about land affairs and special planning based on information technology, by the establishment of a digital transformation roadmap toward an international standard government. Considering the current circumstance, a land service that can be obtained and accessed through online media without the need to do face-to-face interaction is essentially needed. This is in line with the health protocol set by the government in order to prevent the spread of the coronavirus COVID-19 disease. The current land service counter can be transformed into digital counter, hereinafter would be referred as a virtual counters. Jaya in 2020 explained that in order to get full-scale electronic-based service system, it is necessary to have credible land database first. A credible land database could be observed if the data have gone through the validation process to determine the quality of those electronic land documents. Therefore, it is essential to the validation and revalidation to ensure its credibility. In AI or artificial intelligence is one of the fields in the scope of technology that is very popular in recent days. AI implementation, specifically the deep learning that is a part of machine learning, has a significant result on object identification and is widely used to solve problems related to object detection and image classification. Machine learning is a form artificial intelligence that allows systems to learn from data without the need to be explicitly programmed. One of the type of machine learning is a neural network. The development of neural network these days has allowed software to perform something that are usually done by humans, such as voice recognition, facial recognition, object detection, text recognition, text classification, and the others. By utilizing the technology offered in this Industry 4.0, the Ministry of ATR BPN Virtual Counter make use the artificial intelligence technology to enhance its service. TensorFlow Object Detection API and CNN algorithm will play a very essential role on the concept. Hence, this paper aims to analyze land document based on the type and year of chain. Okay, slides. Method of this program is one, separate the test data and training data. Land documents are divided into two major categories: training data that will be used for the training process and testing data that will be used for the testing process. The detailed description of this state is start by collecting data in the form of image, then classification them into two categories: training data and testing data. The images are labeled according to the document number and its year, as well as the page number. A second method is the images are processed by binarization and thresholding approach. Binarization is a process to transform digital image into binary image that have two grayscale values, black and white. Black as the subject marker and white as the background marker, which afterward is transformed into black and white image through the thresholding process to develop a more prominent difference. The following process are segmentation and normalization. These are done in order to separate the object and the background of the image in addition to decrease the image resolution to establish a more accurate detection. Next, labeling and classification. The data are incomplete. The data are then employed as the training data is TFR record, which then will be configured as label map and pipeline to the neural network training. Labeling is given to the parts contained in the book and the existing missing letter. Next is verification and validation. Matching the document to be checked based on the verification result from the data obtained through the training data in the previous process, so that if the document matches, the document will be validated and accepted automatically. This is a network architecture in CNN algorithm. The input layer is a pre-processed digital image that has black and white color that form a convolution and is then processed through the neural network to make downsampling process easier to manage. Each fully connected neuron at the end of the network serves as a number of clays that have to be forecast. The result of this training model would be the data object detection test by employing the TensorFlow Object Detection API. specifically over the object labeling and declassifying process. Okay, next slide, please. This is a process to labeling every object. The first step is labeling is given to the text which has its own characteristic in its document, namely the lane book and the letter of measurement. Next step, second step is labeling is carried out on is part of its document that is a training data. Then, for example, in this lane book document, there are several labels that are characteristic of document that are only in the lane book, namely the name of the right holder, the right of origin, and the date of issuance and bookkeeping of the document. And the next step is the rest is only auxiliary data to improve accuracy in the identification process only. Next. Okay, this is a brief literature review. The first is implementation of integrated electronic service electronic system in land services. The Ministry of HRBPN has prepared to provide service fully electronically with the issuance of Ministerial Regulation HRBPN number 1 of 2021 concerning electronic certificate. Facts so that now all land documents are ready to become electronic document. 2. Land book and measurement book. Land document used as an object of research are measurement book and the land book. 3. The concept of land services virtual counter design. This counter is a digital land counter that can be accessed online for system user in general by meeting standard pricing procedure in accordance with the regulation of the head of National Land Agency number 1 of 2010. 4. Transfer of media for preparation of electronic land database. In supporting the preparation of the land database toward the electronic document, it is necessary to transfer all land document according to the standard as described in Article 4, Paragraph 3, Ministerial Regulation at CBFPN number 1 of 2021. 5. TensorFlow framework and object detection. TensorFlow is a deep learning framework that can be used to create various AI programs. Its use in the field of object detection can simplify the process of constructing, training, and deploying an object detection model. Object detection is a computer vision technique for finding a sample of object in image or video. 6. Convolutional neural network or CNN. CNN work is in the same way as a traditional ENN in that both consist of sets of neurons that optimize themselves for learning starting from the initial input to the final results. Each network will still express a score of what is called wake and layer loss prior that is a loss function associated with the existing class. Okay, my partner can be presentation after me. Let's
Okay,
go on.
thank you, Mr. Doni Ferdiansyah. Next, I will explain the result and discussion of the study. The first, you can see the analysis of change in the format of land book and measurement book from 1960 until now. During the years 1960 to 2021, the land book was changed 7 times, while the measurement book was changed 5 times based on its format. You can see that the change every year on the screen. The land book divided into 7 classes, and the measurement book divided into 5 classes. Okay. This is the detail of analysis of change in land book from 1960 to 2021. Okay, you can see the logo look like a globe, and the title of cover is proof of right. Use the old spelling version of Bahasa, wet and use wet paper. Next, logo is still the globe or old logo, and in 1981 to 1990, the logo image on the first page of certificate is Garuda or eagle. The title of the cover is Land Book, still use a white paper. But in 1960 to 1991, the rating of the certificate has used the old spelling version of Bahasa. But after that year, after 1990, the rating of the certificate has used the new spelling version of Bahasa. Okay. In 1991 to 2021, there are several similarities. First, Garuda logo using green paper with the new spelling version of Bahasa. Then the title not a proof of right, but is a line book, and there is a very small watermark that reads the National Land Agency. Then in 1999 to 2000, publisher is the National Land Agency, and in 2001 to 2015, publisher is National Land Agency, and starting to use NIB or parcel identification number. This is a primary key of parcel land database in Indonesia. And the last, in 2016 to
Sorry to interrupt you. There are 2 minutes left, please.
okay, in 2021, publisher Ministry of Agraria and Spatial Planning, our National Land Agency use NAB or parcel identification number. Okay, next, this is a analysis of change in measurement book from 1960 to 2021. You can see that's the difference. In 1992 to 2021, use green paper, new spelling of Bahasa, there are many watermark and read that read National Land Agency. Okay, this is based on table 3 above. It can be inferred that the early the document were published, the lower the accuracy of the object detection that happened because of the image level of visibility on the older document are lower than the more recent ones, and influences the detection process. The result of the analysis in the table beside are in the land book and measurement book. Under 1997, the average number of object data was 85%, and the average value of the object detection accuracy rate in the land book document test is 86.4%, while the average value of the object detection accuracy rate in the testing measurement book document was 8.7%. And after calculating the
Fajar and Donny, we want to get back to the question. So can you wrap up in the next minute just to give us a quick summary of the final part of your presentation?
Okay. The final accuracy is 87.3%. This is the concept of flow of online land service. There are 3 roles: the user, system, administrator. The system starts from the user logging into the system and then selecting the station services, uploading the document requirement, and next, and in verification data, we can implementation of TensorFlow framework. Upload will file will detect the authenticity of the file based on pixel color. Then the system will determine the file is measurement book and land book, which was published in what year. And conclusion, based on the finding and the test performed to the system, it can be inferred that both TensorFlow object detection API and conventional neural network are appropriate to use in order to build a system that can identify and classify objects. Specifically in this research are line document, line books, and measurement book. The test to determine the level of accuracy of the object detection to the document based on its type and year, so that the early the document were issued, that the lower the accuracy of and the reliability of object detection. In addition, the overall average percentage of object being correctly identified are 87.3%.
Right.
I think that's all. Thank you.
Thank you very much, Fajar and Donny, and well, certainly for your comprehensive coverage of the format of the Indonesian land books over the last century, but also very interesting last comment. You give us the percentage of 87.3% accuracy. I'm sure that will spark a lot of interest within our group. Now, I'm going to ask our backstage help if we could perhaps bring all the speakers, if they're still with us. I know some people are up quite late here and others are up quite early, back onto the screen, because we have about 15 minutes to wrap things up here. Charles can be brought back on too if he's there. It seems not fair to leave him out. So there he is. So we've actually been compiling a number of questions and throughout the session. So thanks for everyone who's been contributing through those. And I think we've got quite a bit of time to go through most of them. And I'd like to do that now. As you can see, this whole session was built around maintenance and modernization aspects of land administration and cadastral. And I think we've had a real full coverage of issues around day-to-day updates versus system upgrades or improvements on a greater scale. So thanks to all the presenters and what they've brought along. I think the first question, it's great to see Mike Barry joining us. First question, Charles, if I'm right, was from Mike, and I think it might have been one addressed to me, so I'll jump in on that one. You're asking, Mike, what's the difference, if any, between maintenance, operations, management? Yeah, what's all in a definition? That's a good point. So difference between maintenance and operations management. I think in the native speakers, they would tend to think of maintenance as this day-to-day operations. But if we actually have a look at the concept of maintenance, how it's used in our discipline, people seem to refer to maintenance as that ongoing systems upgrades as well. And that's why in that conceptual model or that framework I presented at the start, the starting point was maintenance, and then we broke it down into upgrade and update, or the day-to-day versus the sort of the full system improvements or enhancements. Operations management's obviously part of that. And probably a broader part of any organisation's management regime or government activities. But in the work that I was showing, I wasn't really considering, the day-to-day operations of HR or finance. This was really about the spatial and technical aspects of land administration. Charles, you want to go with the second question, which I believe it could be one that all of our speakers want to tackle, but perhaps it's most relevant to Tim and maybe Brandon. Do you want to put the question out there?
Yeah, sure. So the other question is, what's the benefit of free network adjustment? So.
Oh, no, that's not the one. I was going in order, Charles. I was thinking we'd start with the how do we deal with the alienated ownership rights, which I think is really dealing with the issue of 2D, 2.5D, and 3D. 3D, okay. Yeah. Tim and Brandon, I mean, do you want to have a response on either of those? How's Esri looking at this issue of 3D? I know, Brandon, you mentioned about the Australian context. I know at the moment there's a project around there to build a 3D data model that builds on its land XML standard. So have you got any updates or info for us on those aspects?
I'll defer to Tim on that one.
Yeah, so the parcel fabric data model does allow 3D aspects of it. So there is kind of a framework there and a foundation to support 3D, but we're still working on development, and we're in the development phase for the next mode, which is 3D cadastral, support for 3D cadastral. So that's still kind of on the road ahead. It's
okay.
Yep.
And Tim, maybe, so we've got the comment from, and that was a question from Anthony Beck, by the way. He also mentioned around this 2.5D, which is somewhere in between the two. So typically, how is the third dimension handled by the parcel fabric at the moment? Is it as an attribute, or
it's more it's more like extruding data. So it's we'll use an attribute to extrude kind of planar geometries. So it's more or less 2.5D, but something along those lines. We don't have full support for multi-patches and so on within the fabric yet, but that is coming.
Okay, great. Thanks, Tim. I think, Charles, the next question I see, and you can correct me if I'm wrong, is one from Jean-Francois Beaupré. So hello, Jean-Francois. I hope all is well in Quebec. And he's asking a very timely and relevant question, given all the work going on with ISO 19152 and the upgrade, to use the words we've been using, of that international standard, the Land Administration Domain Model that's currently going on with the working group. And I think this could be of interest again to Tim and Brandon, but perhaps also even Martine. How is that standard? How does that influence the different technology or software and for Martine, the platform you've mentioned? How does that influence the thinking or the work going on at both Swiss Topo and perhaps we'll start with Esri?
Yes, Esri
go on.
So Esri definitely does support LADM, and in fact, maybe an easier way to think about it is the parcel fabric is flexible and configurable, so to different data models. So it is definitely able to accommodate that, and we also support. We have released country profiles, such as Colombia, as well, to support that. So yeah, we definitely fully embrace that.
Okay. Thanks, Brandon. Tim, did you want to add to that at all, or perhaps Martine?
I'll defer to Martine if she wants to respond.
So just to be clear, the question was about the ISO question? Yeah,
the LADM standard, is that something, and it's quite all right. I know you're up and coming student there, but I'm just wondering, is LADM on the radar of Swiss Topo at all? We know that in Switzerland there's the Interlist standard, and they do things their own way there. So always interesting to know the relationship between what's going on in Switzerland and the ISO standard.
Well, honestly, unfortunately, as I'm not really in Swiss Topo, I guess I can't really give a full answer. But yeah, for the PLCadast, we use our own text modeling language, which is called Interlist. So, but yeah, about this specific ISO in other fields of Swiss Topo, unfortunately, I can't really answer you.
Okay.
But maybe because I saw some colleagues which are watching us, so maybe they can comment to answer the question.
Yeah, and we've got the LADM workshop. That's maybe a bit of a plug there coming up. I think it's on Thursday for most people's time. There's a full day LADM workshop with Crit Lemon, Peter Van Oostrom, and many others who are central to that standard. So that's just a free plug there for that.
Yes,
Charles,
so if I could just jump in real quick. So that we don't support like an LADM model out of the box. It's not like you're going to be able to get all of the fields and so on with the parcel fabric. But as Brandon mentioned, it is a completely configurable system, so that for any of your tables, you can add your own fields, you can create relationship tables and so on to external tables. So so in that sense, the parcel fabric is configurable to support LADM.
Thanks. Great, Tim. Thanks for the clarification. I think, Charles, our next question is again from Mike Barry, who has questions relating to the least squares I think it was in the presentation from Brandon, or maybe it was in Tim's. Now I'm showing that's too early for me. So what's the benefit of this free network adjustment that you mentioned in those presentations?
Yeah, so in a meets and bounds system where you have a bunch of points connected via dimension information like directions and distances, you want to be able to exclude the influence of the control points themselves and just be able to check consistency within the network without the influence of the control points. Because if there's any error in the control points, that kind of influences the results of the least squares. So you want to be able to exclude those, and that's what the free network adjustment allows you to do.
Great, thanks again, Tim. You're being very generous with all your answers here in this session. Another one from Mike. So Mike's very active. Must be a good time of the. I assume Mike's in Calgary, so he's must be enjoying his evening there. So would a form of conditional adjustment be more rigorous in identifying errors or inconsistencies? I think that's another one that's for you, Tim.
Yeah, thanks, Mike. I don't know if I understand the question very well, so I don't know if I can give you an intelligent answer, but I'm really happy to follow up with you afterwards and we can kind of chat more.
Well, that is a good plug for the Ask Me Anything session that's on right after this. So if you're free and interested in Able, there is a link, I think that's been pasted into the chat, so you can join any of the speakers that are available to discuss further any of the issues or content we've covered in this session. I'll jump forward to the next one. Charles, you want to read out the next one?
I think that's from Barry again, I guess, right?
I think it's the one about beacons and monumentation.
Yep. All right. So if an original beacon or monumentation is placed incorrectly, that is the plant data does not match what is on the ground, how do you deal with the two different sets of data from the same point in the least square adjustment?
Yeah, it's another good question to maybe take offline, but generally speaking, and I suppose one way to do it would be to weight the incorrect value or exclude it from the adjustment, or weight the incorrect one very low. Again, I think that might be better to understand more of the context of what's the questions being asked, because I'm not sure I'm giving a.
That's one for the surveyor to sort out in the ground, right? Isn't it? Yeah, go put this.
Yeah, I'm not sure least squares adjustment's going to help you find. Yeah, it depends.
Monuments over measurements. Last question, and this is another one. Thanks from Anthony Beck, and this one's for you, Martine. I'm assuming, so this is relating to your PLR Cadastral and how you get all those different layers coming in from the different agencies. And his question is, I'm assuming that what you've mentioned there is all based on spatial indexing and that there are different spatial accuracies with these data sources. So the overlapping of the different data sources and those different interests and public restrictions. How do you deal with false positives in those results, or how do you deal with issues of the overlap between the spatial accuracies of the different data sets, or are they all aligned because Switzerland's so well measured?
All right, so thank you for the question. Yes, actually, that's true that all this data come from different sources which didn't have really the same needs in accuracy. Unfortunately, again, I'm not that much into the technical aspects of the PLR Cadastral, but I trust that information about accuracy is present in the metadata.
Yeah.
And this way, we can see which plot of land is considered by the restriction, which can give the resolve the problem of this overlapping problem.
Great, thank you, Martin. I think there's a lot of that's always an ongoing issue with, and I think we saw some of the solutions to that also in the presentations from Tim and Brandon about dealing with those overlaps or different discrepancies between data sources. Now, I am going to, because we're sort of out of time now, and there's still questions coming in. There's another one from Jean-Francois, who's asked around the references to general legal basis where necessary. And that was at Martine. And Daniel Stoidler has said that LADM is on the radar for Swiss Topo and the Swiss data model in general. Swiss data model is 20 years old, thus older than LADM, but of course fully compatible with LADM. And now we've got Crit chipping in. So what I'm going to suggest is, I was planning to do a final ring around, as in a final statement from each, but instead of doing that, I'm going to invite everyone to go to the Ask Me Anything session. But I do want to invite Charles, if you will. Do you want to give us a final wrap-up summary statement before we head over there?
Sure. Before we get for our flight from the world tour, I think the 4 key takeaways from this session. So firstly, the quality assurance is very key to maintain accuracy of cadastral information. And then the Parcel Fabric sets the pace for simplicity, data standards, and validation. And then we go to Martin, who says the legal provisions and legal basis for the cadastral data enhances the legal safety of land parcels and property. Then we come to our Asian friends, who also highlighted the need for the digitization of data with segmentation, using convolution neural networks, and also Industry 4.0 as considerations for the future. So it was a really wonderful tour, and glad to be here.
Thank you very much, Charles, and thank you very much to all our presenters from the US, from Switzerland, and from Indonesia, and all the participants in the chat and the comments. They were great questions. So really great to have everyone here. And a special shout out and thanks to the team behind the scenes again, Christelle. It's quite late in the Netherlands. Christelle and Paula, they were behind the scenes helping us make sure everyone was on the screen at the right time and facilitating everything. So thanks very much to that. And with that, we'll close the session and we'll see you over for post-session drinks, I guess it is. I'm going to have a coffee. Let me ask me anything for those who are available. Thank you all.
Thanks, Ron, Charles.
Thanks.
Thanks, everyone.